Hey everybody, this is Alex Merced from alexmercedcoder.com. This is going to be some more advanced SQL. I'm going to get into things like relationships and whatnot. So first we'll just build out our initial data. So what we're going to do is we're going to go inside of Postgres in our terminal. So let me just go here, PSQL. So I am in Postgres, and what I'm going to do is create a new database. I'm going to create a database, and we're going to call it dogs and owners. Okay, semicolon, because we always got to end our commands in semicolon. So we create the database, wait for it, and then that confirms that we did it. Create database. Now I need to switch over to that database, so \c dogs and owners. You are now connected to database dogs and owners as user Alex Merced. Wonderful. Now if I take a look at how many tables I have here, by doing /dt, which is like display tables, did not find any relations, meaning there's no tables yet. So first I need to create a table. So we're going to create a table called dogs. Okay, and what we're going to do is create a table called dogs, and dogs are going to have a field called ID, which is going to be serial. Actually, ID of type serial. Okay, which is serial just means a sequential number, so it'll be like 0, 1, 2, 3, 4, 5, 6, 7, 8. And they're going to have a name, which is going to be a string, but in SQL, that's varchar 30, or varchar whatever number of characters you want. And then we're going to say they have an age, which should just be a int. Okay, an integer. So this will create a table called dogs, and then the schema for dogs is this. Cool. And actually, I'm going to add one more thing to it. Owner ID, which will also be an int. Okay, the table is created. Okay, now to create a few dogs. Okay, so we're going to use the command insert. So we're going to insert into dogs, and then we have to select which fields we want to give them. So we're going to give name and age. I'm not going to give ID. Serial will automatically give an ID, and I don't have any owners yet to give IDs of. So name, age, and the values we're going to insert are Fluffy, who's of age 5. Okay. And then I could enter another one. Forget if I have to put a comma there. I should be able to do this, like Fluffy, and then Spike, which is age 6, and then semicolon. I think that should have entered both of them in there. Yep, inserted both of them in there. Okay, so now I have 2 dogs. So just to make sure that they're there, let's take a look at show all from dogs, semicolon. So this should show me all fields from dogs. Oh no, select. Select all from dogs. So there we go. So see, they already automatically have an ID. Okay, neat. Now we want to create the owners table. Create table owners. Okay, and then we have to specify what's the schema for owners, which is just going to be ID against serial, and name, which will just be a varchar 30 again. And that should be good. So the table is created, and now let's add some data to that table. So insert into owners, and then we're just going to give us a name, values, okay, Bob, Susie, Mark. Oh, no, it should be this way. Bob, Susie, Mark. Oh, hi, Mark. Let's see here. There, we've inserted 3 in there. Good. Let's take a look at their IDs. Show select all from owners. Oh, semicolon. There we go. So Bob, Susie, Mark, that's 1, 2, 3. Okay. 1, 2, and 3. So we're going to want to do that. Now we're going to want to give some of those dogs an owner. Okay. Okay. And then so first we'll make Fluffy. We're gonna update Fluffy. So we're gonna say update owner ID. Okay, actually we're gonna update the dogs table. Okay, we're gonna update the dogs and we're gonna set owner ID to be Susie. So that's ID 2, where the ID of the dog equals 1. Okay, so that will set Fluffy's owner ID to 1. Okay, and let's just do the same thing again, except now we're going to say owner ID is 1 Bob, and we're going to say that we're doing it for Spike. So now Spike's owner is ID 1. So now if we go take a look at the dog column, we see that now Fluffy and Spike have owners. See, they have an owner ID. Awesome. I'm just going to add one more dog. So let's just go back to my insert dog command. Insert into dogs. Butch and Mittens. There we go. We have 2 more dogs, but those dogs don't have owners. They're strays. Okay. And then Mark doesn't have a dog. Okay, so now we have people who have dogs and don't have dogs. We have owners who have dogs and don't have dogs. We have dogs who have owners and don't have owners. So now we can start exploring the different types of relationships. Okay, cool. And So now if I want to bring up data that has a relationship, what I do is I'm going to do select all. I want all the data. I could always specify columns that I want specifically, but I want all of them for now. From dogs. So I want everything from dogs. So dogs is going to be, think of it as like a Venn diagram where you have 2 circles overlaying each other. So you have a left circle and a right circle, and then they overlap in the middle. So the first table I select, so dogs, that's going to be my left circle. Okay, so I'm saying from dogs, I want to get everything. And I want to do an inner join, okay, which means I only want the results that overlap between the 2. So I really only want the results where the 2 circles overlap with each other. Okay, so I only want dogs that have owners, and I only want owners who have dogs. Okay, inner join, and the table I want to inner join is owners. Okay, is owners. And then I have to specify where they connect. So I'm saying on, I want to say only join it where dogs dot owner ID equals owners dot ID, because that's kind of how they relate to each other. The dog owner, the owner ID on the dog table is what connects to the ID on the owner table. So now when I do this, see, I get Spike, who is who's owned by Bob, and I get Fluffy, who's owned by Susie. See, I've related the data to each other by creating that ID field. Okay? So there's a relationship between the data, and through my query, I'm able to bring up the data in its related way. Okay? Now, I may or may not want this ID field because this is kind of redundant. So what I may want to do is just have this field here and not this field here. So maybe I want to refine that query a little bit. So instead of just selecting all, I really just want dogs.id name, dogs.name, dogs.owner ID, and owners dot name. I don't need the owner's ID because technically the owner ID already kind of covers that. Oh, so now if I hit that, see, now I get the field. I get this. I get a subset that might be more informative to just tell me which dogs belong to which owners if I don't really care about the age of the dog and I don't want the redundant ID fields. Okay, so that's pretty useful. That's nice. Okay. But see, this is an inner join, so it only gets me, so notice none of the dogs that don't have owners and none of the owners that don't have dogs don't show up. So what if I want to join them, but I do want all the dogs to show up, whether they have an owner or not? This would be referred to as a left join, because again, dogs, the first table I mentioned, is the left circle. So I would change this to a left join. Okay, and let's take a look at the results. So now we still get Mittens and Butch. So even there, so basically I'm getting everything in the left circle and everything that overlaps between the two circles. So again, if you imagine those two circles as a Venn diagram, you kind of see what it's doing. Okay, so because I want all the dogs regardless of whether they have an owner or not, but if they do have an owner, I want that information. That's essentially what I'm doing here. But what if I want the opposite? Okay. What if I want everything, all the owners, regardless of whether they have a dog or not, but I don't want necessarily all dogs? Okay, then I would do a right join, because again, the table that I join is the right circle. So I'm saying I want everything in the right circle, meaning all the owners, regardless of whether they have a dog or not. So see, I get all the owners, Bob, Susie, and Mark, even though Mark doesn't have a dog. What if I just want all the information? Then what we're going to do is it's called a outer join. Okay, well I think we'll just type in full outer join, which just means everything. Okay, so you get everything. You get all the owners and all the dogs. Okay, so we can see here's the owners. Here's all the dog. This is an owner without a dog, and dogs without an owner. But see, Mark's ID is missing. Okay, so maybe I'd rather have it where we have the ID column from the owners table instead of the dog's owner ID column, because Mark's not going to have an entry in there. So I'm going to want to alter that. So I'm going to change this to owners.id, but I don't want it called ID because that's redundant. We'll have two fields called ID. So what I can do is I can rename it by saying owner's ID as owner ID, and then I can rename dog ID as dog ID. Okay, the as keyword just says, hey, take this field and give it a different name. So let's try that out and see. We get dog ID and owner ID, and I can now see, I can see that Fluffy and Susie belong together, and then their IDs. But Mark of ID 3 has no dog, Mittens of ID 4. So maybe I should introduce Mittens or Butch to Mark. Maybe he wants both dogs. Okay? I can do that. So this is essentially how you do relationships in Postgres, in SQL. Okay? And there's things you can do also as well. Let's say we want to delete data in a table. Okay. Let's say I want to get, let's say, let's say someone, Butch escapes. Okay, that's probably a more humane example. Butch escapes the shelter. Okay, and I want to remove uh, Butch from the table. So I'll say delete from dogs. So we're always referring to the table. Delete from dogs where, and then we have to put a condition where ID equals 3, because Butch's ID is 3. Okay, so Butch's ID is 3, semicolon. Okay, we deleted one dog. Butch is no longer around, so now if I do select all from dogs, we see all the dogs. Okay, but Butch is not there anymore because Butch has gone away. Okay, so that's how you can delete. So we've seen how you can update. We've seen how you can create a table. Okay, now if you want to alter table, like let's say I wanted to rename the age column to oldness, I could do this. I could say alter table dogs, rename the age column to oldness. Okay, and I've altered the table. Okay, dogs and owners, and now if I do select all from dogs, okay, see now that table's been renamed oldness. Okay, so all pretty straightforward stuff. Yeah, and I mean that's basically how you would manage data in SQL at the basic level. So basically, you create tables, you create databases, you create tables in that database. And now, if actually I do the DT, I can see that there's 2 tables in this database: dogs and owners. Okay, let me just think if there's any other good low-hanging fruit as far as SQL commands without getting into like really crazy concepts. Let's see here. I mean, there's aggregating functions. Okay, so for example, if I want to get the average age, okay, so I could do like select average age from dogs. Okay, that should average out the ages. I think it's like select average. It's been a while since I've done these functions. No, I used it right. I just forgot that I renamed this field oldness. So I want to get the average oldness from dogs. And see, it gives me the average. Okay, so there's the different functions like that. Or if I want to get the sum of all the ages, I can do sum from dogs. Okay, so see, that gives me the sum of all the dogs. So there's some fun stuff you can do with SQL. But the main thing is to understand sort of how these relationships get created when you're creating related data, because technically your applications are going to be pulling in data by sending SQL queries to your database. Now, a lot of times when you're building a web application, you may not even have to worry about the query, because basically you'll be using what's called an ORM, an object relationship mapper, which is going to have some sort of codey way. So if you're using like JavaScript, it'll have a JavaScripty way of interacting with your database. And that ORM is going to be doing all the SQL queries for you. But understanding these SQL queries allows you to go back into your database, examine the data, query the data, make sure that all the data is being used the way you think it is by your ORM, etc. So it's good to know SQL. Also, if you wanted to, you could just connect directly to the database using the core database drivers for that language, which for Postgres would be PG, and then just connecting directly to the database and sending in SQL queries directly. You could do that as well. So my name is Alex Merced from alexmercedcode.com. Hopefully this was a fun video showing you some cool stuff in Postgres. My name is Alex. I'll talk to you guys later on.